Hello and welcome. I'm Bill Wake. We're here working on a Swift program to compare tunes for their similarity. And we've been doing pieces of it, and we've got a parsing code analysis coming, which gets the shape of the melody. But lately we've been working on time signatures, and we've done several of them, but we haven't yet done free meter. So if we take a look at the input file format we've got, there's an M field, and you can have things like 6/8 or 4/4. You can use C for common time and C bar for cut time, but you can also do M none, which means it's in free meter. Okay. Oh, and you can also do well, I've heard it called additive meters, or I guess complex meters, probably true too. But 2 plus 3 plus 2 over 8, it tells you there's kind of a bump, 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 bump kind of rhythm going. All right, and we don't have to have parentheses. All right, if there's no M field defined, it's free meter. All right, well, let's see. That should reflect that. Good. Yeah, there's an issue coming up with quantization because we made a decision there that a measure should just, if you're quantizing it, it should just fill in however many notes it needs to get whatever the time signature said. The free time signature kind of says like infinity. So I don't know. We'll have to decide something on that. But first we have to handle it. Okay, so we have ABC parser. Actually, I guess we're more interested in meter parser. And meter parser tests. Yeah, there we go. All right, so meter parser tests. So we've got M, our kind of helper method, loads up a body, which is a meter spec, and parses it and makes sure we get the expected value. So we check 3/4, 3/4, and so on. And we're really just making sure that the parser produces something of the right type. Okay, so with meter, I think we haven't added free yet. So we need a case for this free situation. And once we do this, there are going to be several places that want exhaustive switches. Okay, so let's free return rhythm. We'll just say 4/4 for now. Okay, that's not the right answer, but we're just trying to get this thing in place. Free return. Well, I think we can just say free. Okay, and I believe there's a couple other places that care. Good, okay. Okay, now this, I don't know the right answer here. My inclination is to just pick a large number and say it's that. Because we're answering the question like, how much can you accommodate? And if it's common time, it's 4/4, 4 beats of quarter notes each. So it could be 4 quarter notes, or 8 eighth notes, or 16 16th notes, or you can mix and match as long as it adds up to 16 total beats. Or, well, I guess you'd say 4 total beats, but but it's not clear what to do with this one. I mean, well, let's make a tentative answer and then see how we feel about it. I'm gonna say check meter rhythm. Let's do free, and then the expected rhythm. I'm gonna punt it a little bit. Let's just say there's a max rhythm or something. Default free, let's just say free rhythm. And this is free rhythm, free meter. Okay. And I don't want to have to make a big decision here, so I'm just going to make something up. Public static free rhythm equals rhythm, and then I'm going to say 1,000,000 over 1. Okay. And that test should, well, that should build, but it should fail. Let's run it. Well, that would do it. Type meter has no member free rhythm. Did I spell it right? Oh, I made a mistake in here. Var. Okay. Good. Okay. And I think our complaint should be the meter doesn't match. 4 is not equal to 1,000,000 over 1. And Swift lets you put these underscores in. I find it helpful sometimes. Okay. But here, let's just return free rhythm. And that should pass. That should catch up eventually. Okay. All right, so we add meter.free. That's probably enough. Okay, so that covers the existence of it, and it answers the question kind of like what's your expected rhythm or your max rhythm or something like that. We have to kind of reinterpret it because these all have a defined amount, but free does not. Okay, now, okay, there's meter tests. Okay, we got the same issue. We want to check that we compile it. So let's try check meter. I think it was open, right? OPEN or none? None. None. Meter.free and free meter. Well, that's not quite what I wanted. Okay, I don't think I need this for now. All right, and this should fail. Our parser doesn't have any idea this is coming. Okay, we expected C. Well, that's not really quite the true situation, but let's go look at the parser. Okay, so here we have numeric meters and C meters. We say numeric or C. If it's not one of those, then we use the last one to get the message. That's why it says expected C. We can change that. Expected numeric, well, expected a valid meter. All right, so let's run that test again. All right, and now we get a better message. Okay, so parser. All right, so now I want to make a parser for the free meter, the none parser. Free meter parser equals, well, it's, I don't know, we don't have a better way to do this really. I played with it a little bit off camera and I wasn't getting what I wanted. Okay. So you match the letters N-O-N-E, then you get what you want, hopefully. I would really rather have something that just says match N-O-N-E as a single string. All right, let's add free meter parser in here. Oops. Oh, it needs to produce a meter. In our case, it's just meter.free. We don't need a separate routine to do it. Oops. Yeah. This should go green. Good. Okay. Well, that was easy. Okay. Let's take our win there. Add support for m:(none), which is free meter. Now, I mentioned the quantizer. All right, handle free meter. We've kind of done that. I guess that's today. It was free meter and meter changes. And this is all part of this. I don't know. I have this kind of three-way device going here. I put my first kind of, I don't know whether you want to call this an epic, but it's a story that covers a bunch of little stories. So it's a bigger story. The current big story, I treat this part as a stack. So this is what we're going to be working on next unless I rearrange it. And then the rest of it is more or less a queue. It's just kind of mostly ideas, not super committed, but things I think I might want to do, and it's definitely not exhaustive. And then down here is kind of the log section that's in reverse chronological. But I'm just keeping track of what we've got. So free meter versus quantization. The issue is, I think I can demonstrate with a run. Okay, so if we, that seems like it should be bound to the top of the screen. Let's make a file. X1, title is test. We're going to go by eighth notes, and the key is G, doesn't really matter. If we said A, B, C, D, E, F, G, A, let's make our meter 4, 4. All right, so we got A, B, C, D, E, F, G, A. That's 2 eighth notes, 2, 4, 6, 8. 8 eighths equals 4 fourths, so we're good. Okay, I don't think we'll need that. All right, so if I get the tune, it's going to look like this. All right, C is lower than A and B because the way musical scales work. All right, but in any case, let's change this. I'm going to make it half as much just to make this more obvious. Okay, so now we have 4 notes. A goes up to B, goes down to C, goes up to D. All right, now we are not quantizing. Let's see, can I make this? Yeah, so quantized, we're going to take the eighth notes. Well, we're gonna take things at a quarter note level. So we expect the same pattern because they're all quarter notes anyway, and we're good. Now, if I take off the last one, so I said I'd have 4 beats, but I only have 3. Let's see what we get. Okay, we get 4 notes. All right, so what it does is it sort of assumes the last one carries over and goes ahead and generates that. Now, well, we'll see if it runs in any kind of human time frame here. If I say no meter, all right, if I don't quantize, if I just generate the report, I get 3 notes, which is fine because meter none says free meter. You can put as many as you want or as little. But if I quantize, because we take the last note and quantize it the rest, I'm going to get 1,000,000 notes. I'm just going to blow up, or it's not going to work. Okay, yeah, it's blowing up because of that. That tells me something's not right. Okay, we went out of range. Okay, there. We don't reduce our numbers when we multiply, and that's pretty much why that creates a problem. So we made some assumptions in quantizing that we could take all the rest of the notes. Now, it may be that my free meter, it's like what's the interpretation of this thing? When I ask you the rhythm, like for most of these, the rhythm is the rhythm. There's no ambiguity. It may be, maybe this should be 0, and we're saying we got to interpret it differently. Instead of saying what's your exact value, or what's a value that's big enough for everything, what if we say I'm not really expecting anything in there? I have no expectations, and we just put the extra notes in. Let's see what we get then. Okay, and then I'm gonna have to record this somewhere to make sure a test reflects our decision. Okay, I want to run it. Okay, X1, title test, L1 quarter, meter none, and key G, A, B, C. That's what we had. Okay. All right, so we have 3 quarter notes. If we generate the report, we should get 3 notes. If we quantize it by quarter notes, I'm not sure what we get there. Again, we made a decision, but I just don't remember what it is. But my hope is it's only going to take the 3. Yeah, it's only taking the 1. Okay, so basically it's saying, what's your measure? Have you exceeded the size of the measure? And I'm going to know to stop then. I think we need to rethink how that's going. Okay. If it were 0, it would, I don't know. We don't interpret it as the minimum. We interpret it as more like the maximum or the exact value. But you can see either answer. If I say it's an infinitely large, or it may as well be infinitely large measure, then we blew up with arithmetic stuff. If I say it's 0, it's as soon as it gets 1 note, it says, okay, we've satisfied your minimum. All right, so our quantizer needs to deal with that. Let me put meter back, since that was our tentative decision. Okay. And quantizer should be its own thing. Yeah, quantizer. Okay, I don't. It's. Well, let's get the test and see what we say we believe. Quantizer test. Okay, so we have a check quantization and measure meter, eighth notes. Oh, this version lets us give note names, and this version lets us give the actual symbols. Good enough. Okay, so quantize a whole note. A, B, C, D, and if we quantize to this, let's see, what's our L colon? Is he getting a tune? Well, okay, we're working from the events more than anything. Okay, well, these are eighth notes, we said. So if you ask for quantized 1-1, we really want the whole note of the whole thing. Okay, and we get A. If we ask for half of it, this has 8 eighth notes, so it's a full measure. The first half note starts here, goes through there, and then the second half note starts at C and goes through D. So AC. Okay. Quantized syncopated rhythms, long, short. Yeah. Okay. So we have a note that's holding for 7 beats out of 8, and if you ask for the quarter note pace of it, the first two get are A because this is A. The second two are A. The third two are A, which takes us to 6, and then number 7 and 8 are A and B. Well, we take 7, so it's also A. Okay, and we can do that the other way around. The first beat is A, second beat is B, but at a quarter note level, the next quarter note starts on B, and the rest of them are on B, so A, B, B, B. Okay, we deal with rests. If you have quarter notes, rests, I guess we expect rests to come out. Okay. This one measures with extra beats, return beats according to the time signature. So if we said it was 4/4, but we put 10 eighth notes in, well, 10 eighths is bigger than 4/4. So we're gonna take the time signatures version of things. All right, and since this explains why our zero rhythm for free doesn't work. It says, oh, you got extra. You said you'd have 0 and you have extra. Well, I'll take the first one, but the rest of it, we're done. We've already got enough notes. Okay, and then here's the one that the opposite. When we had the full one, it blew up because it was trying to build 1 million copies of this, and I don't know. We probably should do some reductions, but yeah. All right. So this one, it says it's 4/4, but it's only got 6/8, so it's only got 3/4. And so when you ask for the rhythm, the first one gets A, the second one gets B, the third one gets C, and then what are you going to do? Well, our decision was let's just repeat. Let's just take the last note and repeat it. Okay, that is particularly bad with our 1 million character free measure, and I would say if you have a partial measure, we probably really just want to do the partial, the front of it. Okay, and if you run out of notes, stop making noise. Let's say it that way. This one held 3 beats. Boom, 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 stop. And we said, no, it really goes boom, 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 boom. Okay, that's not really accurate. The problem, the reason I'm concerned, I guess, it's like, well, why don't we just make it require the right number of beats? Well, there are situations where you don't have the right number of beats. The first one can happen at the very first note of a song. It may be what's called a pickup note, which is sort of a little starter note to get you into the main rhythm. So there's a Christmas Carol, I saw 3 ships, bum, 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 bum. So I saw that I is just a little weak note getting you to the saw, which is the emphasized note. And it's known as a pickup note. And the pickup note happens at the end of the measure. So it's only an eighth note or a quarter note, but the 3 beats in front of it, say, are not there. And even if it's a 4/4 rhythm, you won't have those 3 beats there. And later on in the ending, you will typically make the ending 3 beats. The last measure would have 3 beats to make up for the missing one, because you might sing the song twice, and when you come back around, You don't want to wait 5 beats and sing that thing. You need to make it work out. So bottom line, we haven't dealt with pickup notes. We're taking these implicit short measures and we're just dealing with them with this approach, stretch it out to a full measure. I think this answer is wrong. I think the answer should be on a partial measure, not a pickup note measure. We haven't dealt with that at all, but on a partial measure, you probably should just return ABC. Okay. And so quantize, it's not a pickup measure. It's really a partial measure. And I think what we want to say, quantize partial measures stops when it runs out of notes. A quantized partial measure stops when it runs out of notes. Yeah, I think that's what's really true. And this is going to fail because it's going to return ABCC. Now, I'm assuming the reason we took that easy way out is because it just kind of worked with what we're doing with the quantizer, where it was an easy way to go. But we may have to do a little more work to get things worked out. Okay, so map is the function. It takes a measure, it gives you back a measure. We look at the time signature. We identify the pulses. Let's take a look at that. Yeah, what strikes me is we're not looking at the measure at all to figure out what the pulses are. So this is it's basically it's saying if you, let's say you have a 4/4 measure and you want to quantize to a 1/4 rhythm, then we want to put a pulse in that's at we want beat so far as gathering the pulse. So we're going to append this and start at the 0th one, and then we're going to add in the next one is going to be plus the pulse, okay? And the pulse was told to us, that's the quantized number. So the pulse of quarter notes, say, that we said, well, we're going to quantize by. Okay, so we quantize to them, we add another quarter note. So we're going to add 0 quarters, plus, then the next one is going to be 1 quarter, 2 quarters, 3 quarters, and we're not going to do 4 quarters because that would be equal or greater than the time signature. All right, and this would matter, the less than equal thing would matter if you were quantizing by 3/8 in a 4/4 measure or something weird like that, okay? So what we get back is the array of what are the pulses we should look at? And then the iteration here is to go through those and then figure out what note is there, okay? And measure symbols count. Okay, well, yeah, so we're forcing something. All right, yeah, that's kind of what's going on. It's going through each pulse no matter what. Like, we're not saying, oh, I ran out of notes, don't do anything. Okay, I think we can cure it. I mean, basically, beats if our less than or equal target. What's target? Oh, this is the target. The target is the pulse. Okay, so we're trying to first hit 0/4, 1/4, 2/4, 3/4. Okay, so if we're not at the target, then we have more to do. Okay, and the counter is less than measure symbols dot count. Okay, so the counter is keeping track of which note in the measure is there. All right, and we only want to pull so far. If counter is greater or equal to, measure symbols.count. I guess we come down here and we write out that pulse. We write out that last symbol, okay, and last symbol will still have the old value if we've run out of notes. Okay, I'm not quite sure how to fix it easily. First true measure. All right, so we can we get in trouble? All right, the other thing going on here is you may have, like, imagine you have 2/8 notes, and so let's say we did 0/4 and we're trying to do 1/4, and we have 2/8 notes. Okay, so we took the first measure. Well, let's put 4/8 notes in. Okay, we're trying for a 1/4 quantization. So this beat so far less than or equal to target. That's where we're accumulating how much we've gotten to with our last symbol. All right, and so when you go through with the 8th notes, like the first 8th note doesn't get you far enough to get to 1/4. Okay, the second 8th note does. So we iterate over those 8th notes to get there. All right, but I think there's no point in appending until we've accumulated enough. So we have to wait. We can't append inside the loop. Okay, the trick to me is if the counter is greater than or equal to measures.count, I guess, yeah, I kind of think about that. If we come into that while loop and the counter is greater than or equal to measures.count, we're just falling through the loop and immediately appending whatever the last symbol was. That's a problem. If when we come in on this pulse, I don't know, maybe calculating these pulses like this is not so good either. Is that super helpful? I mean, it's using the time signature. I almost think maybe that's not the way to go. Okay, but anyway, I think one thing we can do around it is if we come in here and measure counter is greater than or equal to measure.symbols.count, then we've already appended that. It was already that way when we left. So we've appended that last symbol and we just shouldn't do it anymore. So let's take that. If counter is greater than or equal to measure.symbols.count, then we're going to return. Okay. Basically, we have nothing to do for this situation. Now, where this may... No, I'm gonna try that. That seems like the change that would do it. I'm still not happy with the pulses and stuff. Okay, what do I know? Failed 2 tests. All right. Who's the other one? Now this one definitely should be... Okay, so short, long, and quantize that. Well, what did he get? Short, long, A, B, is not equal to A, B, B, B. Okay. So beat so far is greater than target. Well, that's not enough to make us stop, right? If beat so far is greater than target, that's great because we've already got enough beats to do what we want. Okay, well, this didn't do it, so let's take it back out. Get down to one failing test. Okay, and make sure it's the right test failing just for fun and the right reason. Okay, we got A, B, C, C is not equal to A, B, C. Okay, that's true. What's up here? Oh, helper. Okay. Now, all right, think about this again. I don't know about this pulses thing. Like if it's a million, I'm generating a million of these things, and that just seems like a lot. Okay. Like I said, I don't know about this beat so far thing, the pulses thing. Maybe I can. I don't know if that's going to help anything. Well, I was thinking about changing the whole thing to another while loop, but I think that may just confuse us. I don't know. We got to do something because I don't want to do a million of these things, when you got 3 notes sitting there. Okay, so how do we know we've gone too far? Okay, it can't be counter greater than measure symbol. And if I have target, I don't know if I'm done yet. Okay, let's take the combinations of these things. I don't know. I'm trying to think of a smaller byte for this. Yeah, let's think of a minimal case. So let's say we got 1 note, we quantize to that. Let's try that case. Okay. We'll ignore this one briefly, but I'll use it for purposes. Okay, so this one is Test quantize minimal measure. Okay, so we're in 4/4 time. We got 2/8 notes, and we quantize to 4/4, and we want to get A. All right, and we expect this test to fail and give us A. Does it tell us here? Yes, it does. Okay, so we get A instead of A. All right, now can I... Let me... I thought there was a way to... Nope. Okay, well, that's back where it was. Okay, let's look at quantizer tests over here. Shut this off. Hide that for a minute. I mean, there's a lot of stuff going here, isn't there? I think what should feed in is like the note we have covered. It covered us to the second note. I don't know. And we asked for 0/4. It was 0/4 up to, but not including 1/4. And we got a quarter note. So the first beat is really that one. And there is no second beat. I don't know. Now, if it was an eighth note and a quarter note, eighth note and a quarter note, then the first one would cover the eighth note plus half of that quarter note. And then we'd come into the second one and we'd say, oh, we still have half a quarter note to go. So something about, I mean, this beat so far is kind of covering it. I mean, I think it's really the fact that beats so far is it about less than instead of less than or equal? If the beat so far is less than or equal to the target, we're going to move forward. Well, if it's less than the target, I understand. If it's equal to the target, I'm confused. Okay, so beats so far is how many beats in your measure have you consumed with the counter? Okay. I don't know if I can write a little logical expression here. Beats so far equals sum of measure sub, let's say 0 up to but less than counter. Okay. Okay, so I think that's the critical thing I'm trying to get at. And maybe there's a concept buried in here because that relationship seems pretty important to our situation here. Okay, so let's see if I'm saying what I want to say with it. So if you take 0 up to but not including counter, and all the measures in that range, beat so far should be their sum. Okay, so in our initial condition, 0 dot dot less than counter of 0 is no notes, okay, no rhythms, and so our sum is beat so far is 0, and that's correct. Okay, then when we get I almost, let me take this off. If beat so far is less than target, then we want to add something. Okay, we're trying to get to 2, 4. Well, let's say we're trying to get to 1, 4 in our case here. We got to 0, 1/8, 1/4, but a quarter of it's equal. Okay, let's see if this breaks any of the others. I'm not sure it's going to solve our test. Apparently it breaks everything. Okay. Well, I'm glad it's useful, but gotta break through here. Right, let's make sure those are back. Okay, I don't. Part of the issue is when you're trying to get that first one, we have this kind of 0 versus 1 issue. Normally a musician counts 1, 2, 3, 4, and the 1 is right on the first pulse. We're saying the sum so far is 0, and that's okay-ish. Okay, so in this first time around, beat so far is less than, well, it's equal target, right? So we got to do something the first time, and that really is the first time we want to take the first note, whatever it is. Okay, so it's less than or equal to target. Well, it's equal. It's 0, and we don't have a symbol yet. Okay, does that mean should I flip this? But target less than or equal, counter less than or equal, less than count is kind of important there. We don't want to access counter unless it's legit. Okay. Now maybe measure and count should start differently. I mean, last symbol is nothing. We put in a fake one. Okay. Um, and maybe we need to put in the first one first. What would that do to us? If you could count on last symbol being there, right? So what if I switch it around? I'll have to worry about a zero case. And I don't know, this little algorithm's kind of the heart of this, so it's a little tricky. This is weird though. I mean, we're saying like there's a 0 beat rest at the front of every measure. I think that's not right. I think we should say well, let's initialize this appropriately. Okay, counter equals 0. Okay, I want to say this should be measure subcounter. Okay, and so we're getting the first symbol in the measure, and measure subcounter is really note. Well, it's a note or a rest. Okay, I guess. All right, so it's the first thing in there. We may have an issue. DVD empty measure could be a problem. Okay, if the counter is 0 and the last symbol is the first thing there, beat so far should be last symbol dot rhythm. Okay. A little more space. Okay. All right. So let's try and flip the loop around to start with things initialized properly. Okay. We've got last symbol and the beat so far. Now when we come in, beat so far is greater than or equal to the target, because the target is 0, so any beats counts is good. All right, and now I think I want to say, if it really is less, then we got to keep going. Okay. There's clearly some little structure or something here that meets this, because they're all being set together. Okay. All right. So if we come in, well, let's just try it and see what our cases say, because I think there's more going on here. Yeah, we're not quite there. Half note quantization, short, long, rests, all these guys failed. Let's just see how they failed. There it is. Extra beats. Okay, I don't care about that one so much. Minimal measure, we get A instead of A. Okay. Long, short, long. We get A, B, B instead of A, B, B, B. A, B, B. Okay. So something's not right in that condition. All right. Can I flip it enough to see? All right. So my pulse is 0, 4. My beat so far is greater than the target, is equal to the target. The target is greater than the target. Target was 0. It exists. We put the last symbol in. Now we come back and we look for 1, 4. All right. target is 1, 4. Beat so far is, well, I guess let's set up an example. We'll use this example. Okay, so we got the first A. Let's make it B. Because it's quantized to a quarter, the B shouldn't matter, but we can keep track of things better. All right, so we get the A, and our beat so far is 1/8. Okay, we come in here, and beat so far is less than target, because we're trying for 1/4, but we're only at 1/8. So we need to update the counter first. Get the symbol at measure sub counter is the B. Accumulate beats so far. Well, measure sub counter is really last symbol. Okay, so add the current measure to the rhythm, and then go back and make sure we're at least the target. Okay, now this is where it's going wrong. Okay, if beat so far is equal to the target, all right, our target is 1/4. We got that a B sitting there, and beat so far is that. So I guess it is less than or equal. We got to be we got to be bigger than the target. Okay. All right, let's see what that does. Yeah, nice. Okay. What test are we on? Minimal measure. Well, that's the one we're on. Okay, let's hide that one for a minute. Check the others. Okay. Why are you not right? Okay, let's take ignore off. Okay, so we come in looking for start over. We come in looking for 0. Our initial value is that first eighth note, 1 with an A. Okay, is the beat so far less than or equal to the target? No, it's greater than the target because we have that A, so we append it. Okay, come back around. Next pulse is 1/4. Beat so far is 1/8, less than or equal to the target. Yes. Have we run out of symbols? No. Okay. Add the next symbol. Counter becomes 1. Last symbol becomes the B. Beat so far is now 1/4. Are we less than or equal to the target? We are. Okay. Yeah, so I think it concerns when we want to append. We really only we would have to stop the loop because we ran out of symbols, and our beat so far is equal to the target. So we didn't really get this first condition met. We stopped because of this. I almost should break out. Yeah, it's like we want to just stop at that point. So what I think is wrong with this structure is we're saying no matter what, we're going to write a new note. Well, that should not be the case. If we're equal to the target, well, if we're less than or equal to the target, then we didn't get far enough. Okay, so we ran out of notes before we got there. So I think this is really, I think this can only happen if beats greater than target. Then only then do we append. Okay, so let me, whoops, beats so far. Requires rhythm and form to comparable. Well, I'm comparing it here, so I think I've got rhythm. I have the equals function. Do I have the less than? Yes. Okay. Comparable. Sorry, why are you not building? Okay, there it goes. Okay. And let's make sure, let's ignore this one. Check the others. Oh, I'm close. Why did this access out of bounds? All right. I don't know why it wants to let me in this measure. Like their version of how I use the stuff is just really wrong. Okay. Like I just want to lock this one in. If I ever need to reference it, please just go to the one I have open, you know? All right. So what I've done by moving this up, I really need to consider counter plus one. Counter is less than that. It's really counter plus one. Because counter plus one is what I'm going to access. Okay. Good. Let's put this empty measure test in. That's a good one. Oh, we need to do the free meter one too. All right. Function test quantize empty measure. I think it should yield an empty measure. I don't see any way around that. Now, I don't know if my thing accommodates it. But. All right, so if you're in common meter 4/4 and you got the no eighth notes and you quantize it, you expect to get nothing back. That seems like a plausible thing. Yeah, and I expect it to blow up because we are accessing this directly. Okay. So I think this should just be a guard because we're not going to cover that case. If measure dot symbols dot count is 0. I guess I need to pick which one I'm doing. If measures dot count better be greater than 0, else just return the measure as is. Okay, because we don't want to do anything on an empty measure. And I think once we know that, we're free to just kind of work on this. All right. Now, okay, so I guess I would say we reworked quantizer to handle partial measure. Maybe it's empty or partial measure. Okay. Now let's deal with the free measure. Oh, no, we can do this one. Quantize a partial measure stops when it runs out of notes. If you're saying AA, BB, CC, then this one should pass just like the other one did. Okay. Now, let's make one for the free measure. And I know it's going to be slow, and I know we need to do something about it, but quantize measure, quantize uses existing notes when meter is free. Okay, so this is meter.free. I think we're going to get a blow up on that timing again. That's kind of a consequence of not, I don't know, of this identify pulses thing. Beats so far. Okay, I guess that's the pulse beats, yeah. All right, so if it's free meter and we do 3/4 notes and quantize at that, it should be ABC. All right, that's true enough. Right, okay. I don't know how I want to fix this. Denominator times denominator. I don't even know why this is. Let's see where this is comparing. It's the old identify pulses. Yeah. Okay, let's print beats so far. That's really obnoxious. How do we get such a big denominator? Well, that's 1,000,000/1. Okay. I almost don't think the time signature should come into it. All right. This number is really obnoxious. It's not a million times anything, so something's funny going on. Let's, can I do this? Five. Well, it's something that bothers me about rhythm, but I don't think you should be using that approach. So I'm surprised it falls away at five. Maybe that's five whole notes. Okay. But what we're doing is we're saying, give us the time signature. We're going to walk through adding up our quantized pulse until we equal the time signature. And if it's a million, then we're going to go through this. If it's a million versus a quarter, right? It's 4 million times. It doesn't seem really lucky. Okay, so what can I do instead? Well, let's see. I mean, one thing I could do is I could ask the measure, what's your total time? What's your total time? That seems like a more productive way to go, right? We're just going to the measure and saying, like, add up your stuff and tell me what you have. Okay, so let's say let's pass the measure into this thing. And we'll use this in there since that's really the only place it's being used. And this is measure of measure. Okay. And everybody should be happy except our one still. Okay. We'll just ignore it. Okay. I don't know. I'm bouncing back and forth on this refactoring versus the other, but okay. So time signature equals measure.rhythm. I would really rather ask I'd really rather ask the measure what its rhythm is. That's the question I really have. Okay, nobody answers it yet. Okay, let me do an undo on that. Okay, what I really want to do is say let time signature equals measure.total beats. Okay, and then I'm going to go up to that. Okay, let's go find measure. Now, I could have sworn there was a way to bounce over to my test. Not B. Okay. It's a navigate. Next area, next editor. Oh, let's make a query. I'm not seeing anything that, whoops, what's this? Cut. Mash everything with an M. Nope. Okay. Anything else? Okay. Let's get measure tests open over here. Measure test. Whoops. Measure test. Okay. So we want to make sure the measure can give us its total beats. Well, all this stuff's going to be useful, I guess. All right, so if we have a note A, let's be explicit about the rhythm. Rhythm 1/8, 1/4, and rhythm, let's do 3/8. Okay. Okay, so we got 1/8, 1/4, 3/8. The meter is going to be, well, let's give it free since we don't really care. Measure dot total beats should be rhythm. Well, 1/4 plus 3/8 is 3/8 is a half, so this is really 1/4 plus 2/4 should be 3/4. And it's getting a value, so I'm just going to kind of make it a getter field kind of thing. Okay. I guess this is public var total beats returns of rhythm. All right, and well, let's just return something wrong for a moment here. Rhythm 3/8. All right, this test should fail. Total beats. Oh, there it goes. Okay, good. 3/8 is not equal to 3/4. Good. Okay, so we want to return. Well, I think it's really symbols dot reduce the initial result. What's this one? Oh, in out. No. Initial result is rhythm dot. Do we have an empty? Let's say 0. And the additive thing, the sum of well, I always have to look this up. Reduce next partial result symbol. Okay, so result symbol in. Okay, so if I gave you well, I think of this as so far and symbol. All right, so I want to return so far plus symbol dot rhythm. Okay, so let's put a break here. Okay, so I'm going to take my rhythms and my symbols, go through them, and start with rhythm 0, 1, an empty rhythm, and add, given the rhythm total so far and the symbol, well, the new result is add this in. Okay, and I think, whoops, I don't know what I hit. Oh, Eric Wang, 1129, welcome. So we're working on an application to compare tunes for their similarity. And one of the things we're doing is some tunes, they have basically, two tunes might have basically the same shape, but one of them has extra beats in it. And so we want to do this thing that we're calling quantizing to say, like, what if everything just used quarter notes? Compare them then. So my examples for this is if you sing the alphabet song versus Twinkle Twinkle Little Star. Twinkle Twinkle has very steady beats. Bum, 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 bum. The alphabet song, when it gets to LMNOP, it's kind of faster. So HIJK LMNOP, you know, it's got those extra beats in it, but it's really the same tune. So we want to make sure that's the case. And we're working on the quantizing. We just introduced a feature that's, you can have, normally you have a time signature like 4/4, but you can also have one that's just free. It says you put as many beats in a measure as you want. And our quantizer wasn't set up for that. So we're trying to make it so that you you work from the total beats that are actually in the measure, not from the maximum capacity of the beats because it's free. And the way we're doing that is, well, I'm doing it wrong apparently. Did that not run? Okay. We're going to do that by calculating the total beats in a measure. So that's what this is doing. Let's see. So back to the quantizer. Before we used to ask the time signature, the measure knew its time signature, like, hey, how big are you? And the free one says, you could put 1,000,000 notes in me, I don't care. And that's not really the size we're after. We really shouldn't go more than the total beats in the measure. So I'm trying to switch that over. Let's see. I think we have a test active for that, or commented out rather. This test, I believe, will fail. Right, it blows up in calculating rhythms because it's saying, oh, you can have millions and millions and millions of beats, and it gets confused. But we're going to try this, which says let's calculate this based on the measures total beats rather than the measures potential beats. It's actual beats versus its potential beats. And this is just a field-like thing, I guess. Okay, so now it's running through, starting at 0, 1, and going up to the time signature. Well, this is, let's call it max beats. Okay, and that should make this work now. Excuse me. All right, so let's get this case. All right, I'm gonna close this window. So our case is if the meter is free, and you're gonna and you have eighth notes. You're gonna quantize to quarter notes. Your eighth notes are A, A, B, B, C, C. The first AA equals a quarter note, the second equals a quarter note, the third equals a quarter note. Okay. Then you should only take the beats that are there. So the first pulse is A, second pulse you got a B, third pulse is C. All right, we did not run all tests. Excuse me. Oh, okay. Okay, that's actually not true. We are not looking at the time signature anymore. Measure with extra beats returns, I should say, what's there. Returns extra beats. I think that's the true statement. And this is E. And let's make sure the failure is probably ABCDE versus ABCD. ABCDE is not equal to ABCD. Okay, yeah, so it did get all the 5 beats, but our assertion was wrong. But this is an appropriate change because now we are saying we will take whatever beats are there, whether there's too few or too many. We're going to take whatever's there and use them. Okay, so all tests should pass. All right, so make quantization work with. Yeah, and the free meter thing is kind of a distraction. We don't really look at it. We don't look at the meter anymore, I don't think. Let's make sure that's true. Okay, let's clean up a little bit. Well, that's... I don't want to deal with dividing by zeros or anything, but really what this is doing is it's taking our pulse, which is up here, and it's basically accumulating pulses. So we're getting 0 times pulse, 1 times pulse, 2 times pulse, and so on up until the max beats. Now, maybe we needed a divide. I don't know. We don't need it anywhere else, so it's a little weird. But if you said take your total beats divided by your pulse, that should tell you how many to use. I don't know if I want to go there right now. Okay. Now, what I'm seeing here, and this is a place where kind of the code smells of it. It's telling me there's something going on, and the domain does not give me any clue. um, what this cluster of things represents? It's sort of an accumulated rhythm or something like that, and we have to look at we want the last symbol. Oh, that's kind of weird. We really are trying to get the beats for this measure. Okay. And yet we need to access the symbol, and we need to access the counter, and we need to access the beat so far. So everything's got to be public on it. That's not great. Like there's something going on. This is accumulating the next one of these things. It's a cumulative beat. I don't know. All right, let's add a question mark thing. Is cumulative beat. Okay. I'm not necessarily going to solve it today, but there's something going on there. And really this whole thing, counter and measure, I mean, it's like built from a measure, and beat so far. Like if I had a function that took the target and it answered does this exceed the target or something like that, then that would simplify a little. And then there's sort of an increment, next beat, next, accumulate next or something. I don't know. All right. Let's see where we are on things. Okay. At this point, everything should be passing. We just want to make sure there's no obvious refactorings or dead code or any of that stuff. Measure test. Okay. Meter. I don't think we've touched. This may not mean anything. I don't know. We introduced meter into the measures because we needed it for quantization, but I don't think we're using it now. Okay. Let's find measure dot. Total beats, symbols, meter. We're just copying the meter over. Okay. Now, the tests, I think we're okay there. All right, let me double check it really ran everything. It's worth a quarter second, right? Okay. So make the quantizer handle free meter. It ignores, well, wait a minute. I think I just deleted a comment is all. Okay, we already said this, yeah. Okay, well, that was a bit of a struggle. Usually we like our features to go in, in 5 minutes, and I definitely spent much more time than that just trying to understand things. There's something going on we can come back to, but I think free meter versus quantization, we solved this. We say quantizer no longer looks at the meter, or goes by actual notes rather than time signature. Probably the real way to say that. Okay. Is there an emerging cumulative beat? Okay, let's move this one down. I may want to come back, but I want to get some other stuff done first. All right, should meter equality work across its cases? Comparing the rhythm. Okay, the deal here is we ask, at least sometimes we're asking, are these two meters the same? And the answer is a little tricky. It's like, this one is 4, common time is 4/4. And I mean, with a musician's hat on, if somebody gave me music that was written with C or written with 4/4 and said, is this written the same way? Yes and no. The fact that the meters are equal is correct. It sort of means they're the same thing. We'd say common is 4/4. And what if somebody wrote it 1 and 8/8 versus 4/4? Well, it takes one whole beat per measure, and so it sounds the same to me. The real case so far, the only place this has come up has been in our assertions, that sometimes we have something that says it's common and the other one was 4/4, and we're like, oh, that's not really the same. Okay. But I'm going to let that go now too. We'll defer the question. I don't think it matters yet. Maybe as time signatures become more important, they'll matter. Okay. But I want to switch gears. So we are using this ABC input notation, and we have this M field, and we now handle things like 6/8 or 4/4, common or cut time. We just finished adding none, the free meter. We handle these complex meters, 2 + 3 + 2 over 8. Okay. If no M field is defined, free meter is assumed. Okay, that would be a good thing to incorporate in. So no meter defined, default to free meter. Okay, so I think we'll pick up there. We're well overdue for a break. Let's take a 3 or 4 minute break, and we'll come back and reset this default, and then we'll work on the fact that you can change meters in the middle of a tune, either in the tune body or in the middle of a line. All right, and we don't have events and stuff to support that yet, so we'll add that. All right, see you in about 3 minutes. Hey, welcome back. All right, so we want to handle this case of if there's no meter defined, it should default to free meter. And I don't think it's going to be hard, but I feel like we probably didn't define meter a lot of times, and there may be a few places that care. We've got the tests here for parsing. Let's find the parse meter. I guess I want an example that has meter in tune header. Okay. Yeah, so I think we can put it right about here. We want to test meter defaults to free meter. Okay, and I don't know, we'll make the same kind of structure. We're going to leave off the meter. We basically won't add anything to the header. We'll just have these two notes, and we'll get the tune first measure in the A part, and the rhythm should be well, what does that give me? Well, I want to say meter.free. But it looks like I'm getting something. Measure. Okay, so you could just open it for me, be all right. How do I get the meter? I guess we're going to have to private set? Oh, I can just ask. Okay. Let's not ask for the rhythm. Let's ask for the meter. There we go. Okay, so if you parse a tune, you give it notes, but you don't have any default. You haven't specified the meter. We should get free meter. So this should fail. I'm pretty sure we default to 4/4 somewhere. Okay. Yeah. So let's see. That's handled in Tune Builder, I think. If not Tune Builder, it's in Event Depart. Okay. So Tune Builder. Default meter equals is the rhythm. Huh. Okay, interesting. Nobody looks. All right, let's go to tune state. That's probably the real place. Default rhythm is common. Okay, so the default should be free. Let's make sure this test works. All right, and let's try the others and see who assumed they had common, but now they have free. Okay. Tune tests, event depart. Well, event depart is probably the more urgent one. Okay. Yeah, he's using initial tune state. He doesn't set it, so he should be free as well. And what about you? Yeah, same thing. So tune knows its measures. We didn't give it any initial meter, so these should be free. Defaults. I think same thing again. It's going to be free versus common. Yep. I mean, there's conceivably a place that cares, but this thing is not referencing any meters. Same thing here. The symbols, and this should be free. Suspect that's what this was. Yep. We've got most of them. Good. Okay. Make meter default to free meter. We'll get a nice quick implementation to make up for the quantizer. Default to free meter. Okay. Handle M in the tune body. All right, that's again ABC parser. In the tune header, we handled it. Let's take that. The tune body, we're not doing anything about M. All right. I'll add this, but this is not the right thing. Really, here we need to add a meter change. Okay, and we're just going to take this out. Okay. Okay, so let's do this. Meter line in tune body. Okay, and actually we know we need to do something first. That's our events. Okay, we have events for key changes and note length changes, but we don't have one for meter. Okay, so this is a meter change and takes a meter. Okay, so if I add that entry, I'm going to get a bunch of complaints here. As note, is note, okay, times a rhythm, that doesn't even really make sense. This one, description, well, we want a meter change to have its own description. These are getting a little crowded. Okay, key change, unit length change. Let's do a meter. Let meter. Meter change. And the meter. Okay, that's just the, that's really more of a debug description. Does anybody get this? Well, I think this would be a better assertion without it, really. The actual rhythm. What is an actual? It's a note. Oh, it's an event. Actual dot. Oh, that's why we did it. Okay. Let's make this debug description instead. Okay, this is where the real work happens. Okay, so case key meter change meter. I don't know if I can do this default. I probably just want to say break. Go back old school again. Okay. All right, so I'm adding, right, we'll get there. All right, so we add meter change to event. Now we'll have to get them working to really be there. We just got a little stubbed. All right, but we have this test, meter in body, and we're going to do this. Okay, and we're going to need two measures. All right, so this one, we're going to start free. We'll do one measure like that. Then we're going to do a meter of 3, 4, 3, 4, and another note. Well, let's fill up that measure with A. Okay, 6 pulses, 6/8 notes. All right, so measure measure 0. Let's get measure 1 as well. Okay, measure 0's meter should be free. And this one should be standard 3, rhythm 3/4. Okay, so the first measure should be free because we didn't set one. We get a line that says halfway through the tune, change it to 3/4, and it should be matched up down here. I almost wonder if standard should just have the 3/4 and the rhythm should be implicit. I don't know. Alrighty, this test should fail. Okay. 0/4 is not equal to 3/4. Okay. I'm not quite sure where 0/4 comes from. All right, but at any rate, I know we need to do tunes.add. Tunes.add, and this is a meter change. And we'll change it to whatever the meter is from the parser. Maybe meter was left at 0/4. I don't remember. Meter. No, it's our 1,000,001. Okay. I don't know why. But it should pass now. No, it shouldn't. We pushed it into the events, but the events don't deal with it. 0/4 is not equal to 3/4. What's meter description? I feel like something's a little weird. 0/4. I don't know where that's coming from. All right. Well, we've added our meter change, but our event to parts doesn't do anything with it. So it needs to. State dot event state dot meter equals meter. Okay, so now we're saying there will be a state change event and future things will use it. Oh. My test may not be adequate. That's what's going on. Measure 1 doesn't exist. Let's put a bar line in here. Okay, could we have a free meter? We'll close that bar line. Well, do I want to do it there? Let's put the meter before the bar line for our first try. Okay, so we change in there, that should be going. All right, let's run this again. Three-fourths is not equal to free. Huh. Okay. Event to parts. And we also had tune state. Tune state starts out free. Maybe event to parts didn't start out right. That's the changes. Yeah, let's look at this thing. State.meter. Oh, is this? How does that first measure work? Okay, it's a little weird. So we are running in, when we start out, we have notes, and we're saying append the current symbols in measure. Well, where is that thing? That's initially empty. But we don't actually create the measure until the end. I think we really need to keep this. Okay, so the order of events is this. It's note, meter change, bar line, note. Okay. And so what happens is we get the notes, we gather them up into the symbol list, and we set their key in note length. All right. And then eventually, well, in our case, we hit a meter change. We set state meter to meter, and then we hit a bar line, right? Bar line next. Well, that says, oh, it's time for a new measure. All right. What should we use for the state? Well, state.meter is what we've got. All right. But that's not right because we've already changed it to 3.4. So I think we have to track that meter separately. All right. So let's keep track of current meter is a meter. And then we have to set it. Well, it comes from initial state, so let's set it here. Current meter equals initial state dot meter. Okay. When does that change? Well, current meter changes on a bar line. So symbols in measure should use current meter, but then it needs to adjust current meter to the new current one. And we're going to come back on this one because it's not Um, we're not covering every case. State meter. Maybe I should be tracking the whole measure at this point. Might be a better thing, but this should work. Okay, so we change meter in tune body. Okay. Now, I think we can create the next one. This one is really before the bar line. Might be one word. Bar line. And this is after bar line. So here I want to put the bar line here. All right, now in principle this should be okay that I'm saying a note, a bar line, new meter. Well, I'd like to apply that to the current measure, but the way new meter works is it says I only apply to the following measure. But we have a special case. If there's no symbols, we have to do something different. So I would expect the same result because of this special case we're saying. But I don't want to make people, I mean, it's going to be true. People just aren't going to do it the right way. All right, so free, it's still marked free because we're free here. We started a new measure free, and if we had a third measure, that one would pick up the 3/4. Okay, we want to make sure in tune body right after bar line, meter line right after how about before well, right after bar line. What does it do? Well, it adjusts current measure. Okay, and that is a special case. An event to parts. Okay, so what happens is we do the meter change. Normally we just let it ride. That's the next measure's meter. But if symbols in measure count is 0, we're going to set current meter equals meter. Okay, so we're adjusting for this special case of no notes yet. Okay. I think that's reasonably okay. We normally deal with that up here. Current meter. Yeah, I don't know if I would be better if these two together should be a measure and we can edit it. Let's take a look at measure. He's a struct. He is editable. These are private now. And really they're read-only at this point. So I'm going to let it go. Okay, so this was handle meter change in tune body. If changing at start of measure, apply to current measure, else to next measure. And the real reason for that is, like, you shouldn't be able to change in the middle of a measure, or it doesn't make sense to change the current measure immediately. You said it was going to be 3/4. You can't stop after 2 and change it to 4/4. All right, you can just change it, but you can't leave it 3/4. Okay. To do. M in tune body. Yes, we've done that. M in line. Okay, so we have, let's see, I think we have examples in the parser tests already. Meter inline, nope. Length changes in body, length changes in line. So it's closer to this one in flavor. Okay, I'm not going to worry about this. It's free. I'm in G2. I'm going to change this to 1/4 time. And this is before the bar line. Okay. So he's free. Let's see. This should be, well, I think we want closer to this assertion. We'll take measure 0, measure 1. We should start free. The next one should be 1/4. Let's make this G2. So it is 1/4. And we'll switch notes just to make sure. Okay, so you're going along in free meter. You say next time you see a new measure, it should be 1/4. And we see the new measure, and this should be 1/4. Okay, and so this should be, I guess I changed that fast and I thought this should be 1/4. Yes, that's correct. Okay, this test will fail. Should be a parser error of some sort. Okay. 0/4. I wonder where that 0/4 is coming from. Somebody out there is doing 0/4. Let's find that person. Empty measure. Kind of think that shouldn't be used so much. Parts. All right. Fair enough. Oh, so we're not getting any measures. Okay, that's what's going on. I probably should have looked at this message first. Parse tune. Yeah, unexpected characters found M:1. And we expected no messages. All right. Well, this is in the note line parser. We haven't looked at that today. Okay, there's key change unit node length. Another instruction we have is meter change. That is a meter parser. Pipe to okay, meter parser's parser. The result pipe to well, it's going to give us back a meter. Well, we want an event. Okay, so let's do event dot meter change with $0. And if we look at meter parser, dot parser, it binds producing meters. Okay, and we're going to turn it into a meter change just like we did in the other. Okay, and this then needs to take meter change. That should do it. Whoops. Oh, it's got to be an array. Okay. And then our next one is we just want to check that after bar line works correctly, although I'm pretty sure it's going to. Inline after bar line, and it's right after bar line. Changes current measure. So we'll put the bar line after. Okay. We don't have any notes until we get here. So this should be, well, it really should be the same, yeah. First measure is free, second measure is standard. All right. Let's run this. And I think this should pass. It's generating events the same way, so it's not going to make a difference. All right, let's add one more test. Meter change inline mid measure changes next measure. Okay, so this one, let's put a couple of notes in here. C2 M1/4 B2. Okay, and I would expect this to be two free measures. And then a 1/4, and we need a measure 2. Okay, so change meter inline changes the next measure. So we're going along free measure, get a change. We say next time you change a bar line, you're going to put a 1/4, A2. So unlike this one, which did it right away, this one's going to delay. And I think this should pass as well. What do I know? Okay. Free. Let's try changing this. Okay. Inline meter change events work. Did I not run all tests? Let's make sure. Okay, good. All right, M inline. Okay, now this one, handle M without L in tune header. Okay, this is more complicated. I'm not sure if it's a 10-minute job or not. So this is an interaction between M and L. All right. A meter change does not change unit note length. That's good. If there's no L defined, the note is set by default based on the meter. Calculate the meter as a decimal. If it's less than 0.75, the default length is a 16th. If it's greater than 0.75, it's an eighth. And if it's free, it's an eighth. Okay. This concerns how we set the initial L. And I think let's see what we get for tune state, note length. I think this is going to have to be an optional. So this way it just hard codes it to 1/8, but well, that's not so terrible if no, we don't know if it was set or not. Okay, so do I care about that from let's see where tune state, that's in Tune Builder. Okay, so he sets the initial state. Well, note length is set here. I don't know. Here I do have a var. Hey, it's a program to compare two musical tunes for similarity, or any number really, and we're supporting this input format called ABC. It's a moderately complex format. I mean, this is like 100 pages of text for the definition, and we've been accumulating features to handle time signatures, and then there's also this notion of a unit note length, which says when you write a note, is it an eighth note or a quarter note, or what is it by default? And we support changing it, but there's a rule in here that if you don't set it, then you need to calculate it a different way and force it to one or the other of these. And the challenge is right now we just hard code the default to say, oh, it should just always be an eighth note. but that really is not true. And you can't tell until really until you are ready to make the tune. Like that's the only moment you know if you're never going to set one or not. Um, so I think what we need to do, well, yeah, I think if you make a tune without having set that, it's a little hairy. The input format is messy, is kind of the worst of it. But then you end up making the domain model pretty good sized. I mean, there's lots of things that sound like musical things, which is cool. You know, that's kind of the way you want it to be. And then the parser stuff is producing these. And so I don't want to make these, I don't want to pollute them with decisions that are really a consequence of the header file or the input file. But this tune builder is in the parser domain of things, and it's the one that's responsible for building the tune. Once it builds the tune, it's kind of the metadata and the initial state and all that are already set. So we just need to make sure that the initial state going in is what we want it to be. So basically, if you created a tune, if you imported a tune without a length set, we need to consult the meter to decide. Okay. So I want to put a test in. I'm also kind of running out of time today, so we may just get the test in and stop there. So let's find the other length ones. Okay. Yeah. So this one, well, one thing is default note length is 1/8 for free meter, which is the default meter. It says I don't really have a time signature. You can just use however many notes you want. Okay. And so if we do a parse tune, parse tune, header lines, we're basically taking defaults, and note lines don't matter. Okay. We should, well, I guess I am going to look at these notes, so I'll make it a little shorter. Okay. If you get that, the default for these should be eighth notes. Okay. So actually I can use this stuff. Okay. So if you parse a tune with no header line, default note length, you should get the rhythms should be rhythm 1/8 and rhythm 1/8. Okay. And I believe this will pass already because we hard coded this default. So that's more to make sure things don't change on it. Okay. Good. And then we need one that says there's cases where it's 1/4 for, well, let's see what the case would be. If it's less than 3/4, it's a 16th note. Oh, okay. I guess I want a 16th note. Okay, so this time I'm going to set the meter to something less than 3/4. Well, 3/8 is less than 3/4. So I would expect these to be 16th notes, and they're not going to be. Okay, so empty, and then see the error. Oh, we have an error. Oh, I didn't put a new line. I'm only expecting 301 to fail, not 299. All right. So yeah, we're getting 8th notes instead of 16th notes. All right. So I think that'll give us somewhere to pick up next time. We can take anything, well, less than 3/4. 3/4 is 6/8. 12/16 and 24/32. Let's do 23/32, since that's just less. Okay. All right. So we'll pick up there next time. That's tomorrow, 1 to 3:30 p.m. Eastern Standard Time, or 6 to 8:30 p.m. UTC. Thanks for joining me, and Eric Olikus Tech, and both of you. Thank you for speaking up, and hope I catch you in the future. So take care. Bye-bye.